All right. I'll do one that's sort of like the one you guys had. Yes. Is this linear?
Yes.
Yes. Even if I did this?
Yes.
Good, because it only cares for the y and the y pieces, right? The y and the derivatives of y. What's the very first thing I need to do now that so this is the key. Categorization is big. Things could be multiple types. But what I try to tell students is, the first thing that comes to mind, just do it, so you're not wasting time trying to figure out what else, right? But although some types will be quicker, though, so you got some competing idea about what to try to do. Are you guys semi with me?
Yeah.
This is linear. Is it separable? Always rule out separable. No, because the pieces of x and y are separated by plus or minus, so I can't. If they were factors, then it would be separable. Does that make sense? If they were multiplying, yeah. So what's the first thing I do? Divide by x. Can make that first thing a 1. Cool. Let's divide p of x. Negative 1 over x. So e to the integral of that business. Yeah, it'll be e to the negative natural log of x. That comes up. These kill each other. 1 over x. Now, the step that people skip, which I don't really blame you, because I would skip it too, but when you skip steps, you got to be careful. Who remembers, hopefully everybody does, because you just did a freaking quiz of it. I could, if I wanted to, immediately go to D stuff, right? But what you really, really should do is go ahead and multiply by 1 over x, so you don't forget this guy changes, yeah? That's the integrating factor. You're going to multiply by what you get here. What I get all the time is somebody will do, this is always going to be mu times y, or times whatever the dependent variable is. Are you guys with me? Mu y is, mu-e. Good old mu-e. So mu-e, bam. But what I get is I'll have somebody put this. And of course that's wrong because you didn't do the integrating factor, right? So there's a competing thing again. Save time, but if you're going to do a shortcut, there's a little adjustment. Oh shit. Okay, let me stop for a minute. Is everybody with me on that? You guys all right? Okay, linear freaky. Linear freaky. Relatively easy though, right? The only thing that can make linear difficult is if this integral is gross. Are you with me? Otherwise, linear is pretty straightforward. I see some confused faces. And knowing me, I could have made a mistake. But what do you guys? Is everybody all right? Are you guys? And then, still some confused, but no questions. I'm just going to keep going. So the y over x equals. How do you integrate that business? Here's what I do. This would have come from x to the negative 2, correct? Yeah. And then negative 2 would have come down, but there is no negative 2, so there must have been a negative 2 on the bottom to kill it. I don't know how you guys do it. Yes?
Oh wait, I don't know if I know how to ask that.
Now I need to somehow know.
Well, I guess, are you technically multiplying by 1 over x with
Yes.
the middle term? Because
Yes. Everything has to be multiplied by 1 over x.
it just looks like it replaces it. I'm confused about
What do you mean? Oh, you mean here?
Yeah.
Okay. So let me do this. This will be 1 over x dy dx minus y over x squared. Now real quick. If I had y over x and I took its derivative, and by the way, it would be d by dx, but I could move dx over here. Is that cool? Okay. If I took this guy's derivative, wouldn't it be 1 over x dy dx? So if I took this guy's derivative, it's a product rule, right? I can even write it like this if I want to, right? So it'll be dy dx times 1 over x. Is that cool? And then it would be plus negative 1, so that's minus y x to the negative 2. That is, in the derivation we did, we realized that once we multiply by the integrating factor, the whole purpose of it is to make me be able to write this whole freaking side as D1 blob of stuff. what kicks ass is when I integrate d stuff, I just get stuff. Right, so integral this is just this. That's what's so beautiful about it. I don't know how you guys feel about like completing the square kind of did something similar, just put shit together and then I can just directly attack it. So it's the same idea here. This process puts all this shit together and then I can immediately just directly attack it. Now the other side becomes whatever the shit it does, right? I gotta multiply by it, I get something, I'm gonna have to worry about it. That's another place where the integral could get a little funky. Are you with me? Because I can put whatever the hell function of x I want to over here, right? I will. Okay. You guys come up with me? Is that all right? Okay. What's that? Okay. All right. So let's do this. I want to very quickly. So we got this. You all right? Okay. I mean, really quick. I don't want to spend any too much time on this, but I felt really bad yesterday. But all right, what I did. A little backstory into teaching. It's very interesting. It's been 7 years since I taught DiffyQ. So what did I do in January? I proved all the theorems in the book, and I did some example problems just to make sure that I remembered stuff. You guys with me? So when I did the derivation, the proof of the integrating factor for exact, I saw that it was separable. I'm like, let me see, I think it's linear. And so I did that linear thing too. And that's what I had in my notes. And then I'm like, oh shit. So I want to very quickly, really quickly, let's see how quick I can do this. Yeah, so at one point we got to this. I wish one of the markers worked. I mean, so we got to this point here. I don't know if you guys have that somewhere. And if we make an assume mu is a function of x alone. Right? If we assume that. Now, in a higher math course, you can come back and say, well, what if it isn't? Is there still a way I could proceed? And there is. It's just obviously going to be worse. Right? Okay. But if I can assume this, and this is eventually sought out to be true, then I can do this process. So if I assume u is a function of x only, that means mu y is 0, and I end up with mu xn equals my minus nx mu. This would be d mu dx equals my minus nx over n mu. And I remember somebody out there trying to save me from myself saying, it's separable, Jeff. And I'm like, no, I did it linear. I just did a linear to see if I could do it. So this is very separable because the assumption we made is that mu is a function of x only, meaning that this must be a function of x only. You with me? So then I can separate it. Right? If I separate it, I'll get d mu over mu equals dx times this business. And just without doing this, can you see this is going to lead to a natural log? Yeah. I'll do an e. The integral of this, what did I do with that? The integral of this is it. I don't know what it is. So I have e to the integral of this. That's exactly what the integrating factor is. Are you guys with me? So separable there, it's relatively straightforward. You could look at this as a linear. The thing that tripped me up, and I'm sorry, I don't want to spend any time on this at all, but, oh yeah. So when I subtract this over, I can make this change like this. I think I got that. Yeah. Equals 0. Mu. So then my integrating factor, I'm going to just use IF, because mu is already in there. You guys with me? So the integrating factor would be e to the integral of p. Let me just put p there. Stay with us just for a minute. All right. Is everybody with me so far? So I could look at this. Again, DEs could be multiple forms. I could look at this as a linear, right? Why did Jeff do that? Because I just wanted to see if I could. So this would be d. So if I multiply by this, see how this side's still 0? So I'm kind of lucky there if I forget. So d integrating factor times the dependent variable. When I integrate this, it's easy. I just get this equals a constant. Guess so, sort of with me? And then if I divide by this to solve for mu, do you see how it becomes negative integral? And then this shit flips back. If you don't quite see that, it's okay. Because the normal way to do this is just treat it separable. But you can treat it linear and you still get the exact same answer. So let's do a concrete example, right? Yes?
How does the C end up getting on the other side, the constant?
On the other side, so when I integrate 0, I get C.
Oh, okay.
And then when I multiply this over, yeah, and then of course I'm going to choose C equal to 1 because I'm
You can integrate 0 with no.
Of course, yeah, of course, right? What do I differentiate to get 0?
Okay.
Constant. So what do I get when I integrate 0? Some constant.
Okay.
And then I'm going to pick the constant to be 1 because I want mu to be as simple as possible because I don't need a specific one. I can use any of this family will work. I don't know. We talked about that before. Okay. All right. I don't know if that was good or bad or what, but it just happened. Forgot I had a pin here. All right. So let's do an example of an interesting kind of problem. And you either think they're all interesting or they're all not. Yeah, this one, yeah, I like this one. Pick up the paper, Jeff. Just in case, I'm going to say the instructions say solve this as an exact, or you verify this is exact and then solve it using that method, right? Very quickly, can you guys tell this is not going to be exact? What's the partial of this respect to y? 0. Partial of this respect to x is not 0, so it doesn't even matter what it is. So how do I determine the integrating factor I'm going to need? Here's what I do for myself to help me, because I know it's going to be this form. Let me see. Yeah. Well, it could be of this form. This is one option. It could be this. The other option could be whatever the hell the other thing was. Let me get it right here. This is what I told you guys. I'd let you write down. Because I always. Yeah. Cool. Because the weirdest thing about doing exact, where you have to do an integrating factor, is which assumption am I going to make? It kind of boils out in the work. You don't have to make an assumption. It just kind of comes out of the work. So no matter what I'm going to do, I have to figure out what my is. So what's m? Let's start there. What's m? Holy shit. What's n? Okay. What's m y? 0. What's n x? 2xy. Now, I build those interior integral exponent pieces. So what am I saying? These pieces, right? They're basically the same almost. So one piece would be my minus nx over n. Well, what would that be? My minus nx over n. In order for that to work, it'd have to be a function of x only. You guys tend to see that this is a function of x only. Because the y's all cancel. Are you with me? So I could do this way. This would equal negative 2x over x squared plus 4. Become an x squared plus 4. Or, if I look at it this way, nx is 2xy, my thankfully is 0, thank you, and then m is x, so this is obviously a function of y only. So like so many processes we use in this class, very often there are two different ways you can go. Sometimes there's only one. So as exact, one of these could have been a function of both x and y. Then you just give up on that one and you go the other one. But this one, I could do it either damn way. And either way I do it, it would come out to be the same answer. Right? So, which way do you guys want to do it? All right, 2y. What's really funny is, well, I'll show you. I'm going to choose the other one. So I only gave you the illusion of choice. So my integrating factor, if I choose this guy, is going to be this. It's going to be mu to the integral, e to the integral, negative 2x over x squared plus 4 dx. Yes, okay. Bye-bye. Agree with me? So you've seen this kind of process before where you identify the parts, you do the parts. You identify the parts you're going to need, you build out of those parts, and you identify which process it actually works with. Right? In this case, it could have done either way. I let you choose, and then I chose the other one because I'm evil. Can you guys see, now real quick, you all know that's going to be a natural log, correct? Yeah. Okay. In fact, the 2 is nice to be there. I can take the negative out, and then it's perfect, yeah? It'd be natural log of x squared plus 4, negative outside. Derivative would have a 2x, beautiful, right? Don't need u sub, thank you very much. You guys kind of with me? And of course, this goes up, this dies, and they get 1 over x squared plus 4. Is that all right? Okay, now in this case, when I put this in, notice what happens. So I'm supposed to multiply this. That's my integrating factor, correct? Whenever I have an integrating factor, the idea of factor is multiply. It's part of multiplication, so I'm going to multiply everything by it. In case you didn't notice this from the beginning, something nice happens. So when I multiply by 1 over x squared plus 4, 0, of course, just eats that up. This is x over x squared plus 4. And this becomes, I know my 4's look like y's. It's just too bad. If you take a y out, these cancel, you just get y. Right? That y comes out, everything else cancels. And of course, now, be careful. Homogeneous does not lead to what this is. This specific problem, from the beginning, was frickin' separable. I don't know if anybody noticed that. From the beginning, this sucker's separable. And of course, why? Because my y and x piece are multiplying, which means I can pull them apart. If they're adding, subtracting, I can't to try to get the x stuff together. Do you guys see that? So be careful. Homogeneous does not always lead to separable, but in this case, it is. Now, is this exact? How do you check if this is like trivially exact? What's the partial respect to y? It's partial respect to x. Okay, that's like trivial exact. If they're both 0, it's freaking separable. Are you guys with me? Okay, maybe. So this specific problem, you could just do separable. Yeah.
What's the first one? 0. There's a y. For ds.
Oh, it's a 4.
Oh, my bad.
No, not your bad. My bad. Okay. Just want to make sure it's not you, it's me. Okay. All right. So, what I want to focus on today is what I got into a little bit last time, which is the we got into it last time, right? The did I just say homogeneous? I think I did. I just said homogeneous. So this is the one where if you replace x with tx and y with ty, you can factor that out. Now, that is really difficult to remember. It sounds like, holy shit, that's kind of a lot of work. So here's the reality of what this means. I have a derivation and all this shit, and it just is no good. It's not. This is one case where the derivation is just kind of silly to do. Let's just do a concrete example and show you what happens. Do I have a concrete example? I think I do. Yeah, I do. Okay. Now, these functions are very simple. But in general, the idea is this. If I can divide by a certain number of x's or a certain number of y's and get functions of y over x alone, no x's, no y, they're just all y over x. So what the hell do I mean? Real quick, do you guys remember the idea of homogeneous or homogeneous? If they have the same, what's the degree of this? 3. What's the degree of this? 3. Okay. And the official definition is if you replace x with t, x and y with ty, you can take out a certain number of t, blah, blah, blah. But it really just boils down to, are they the same degree, right? If I divide everything by x cubed, what was x cubed? Do it, Jeff. There you go. Make it look like a y. Did I just make, especially if I do this, is that essentially a function of y over x? You guys see that? Does everybody see that? Okay, that, when I was taught this method, I realized it boils down to that. If I could take the equation given to me, divide by a certain number of x's or y's, because it could also have divided by y cubed, and that would have only x over y everywhere, correct? There's no random x's by themselves, there's no y's by themselves, they're all stuck in y over x. Everybody with me? So then the idea is simply let u equal y over x. So there's a whole branch of differential equations that you can solve with appropriate substitutions. So in this case, this substitution kicks a lot of ass. It's going to make this separable. If it is homogeneous, or whatever way you like to say that word, and you do the appropriate substitution, it will become separable. And separable kicks ass. If I do this, then y equals ux, correct? That's crazy sauce, Jeff. What's dy then? Oh shit. So we are doing a substitution, just like good old Math 180. So I got to replace dy with stuff. You guys kind of with me? So what's dy? Almost. That's a good start. X d mu. Everybody with me? You guys with me? Wait, what? D mu.
Why is it me or you now?
Huh? Oh, you. Sorry. Sorry. I got too many things in my head at one time. You. Okay. I got integrating factor in my head. That's a condition. Okay. And then dx is just dx. So I'm sort of replacing y, but x is still there. Is everybody with me? I could have gone the other way. Again, I could have divided by y cubed, and then my substitution officially would have been x equals vu. That's kind of, or x equals, vy, sorry. Right, but it doesn't matter what the hell letter you put there, right? You guys kind of with me? Okay. So let's see what happens. This feels gross, but the nice thing is, the light at the end of the tunnel is it's going to become separable, right? So let's plug shit in. So this will be 1 plus u cubed dx plus u squared dy u dx plus x du. Stop for a minute. Again, that looks a little worse than you want it to, but my God, that's not bad, especially because it's about to be separable. So then I get 1 plus, it doesn't matter. 1 plus u cubed dx plus u cubed dx plus x u squared du, just distributed, right? You stop. All right. And then, of course, what do I have like terms? Can I suck this u cubed dx in with this? So now I have 2 of these. And you see how all my x stuff and my u stuff are multiplied. I have separate factors of u stuff only and x stuff only. That is the sign of a separable DE. How you guys doing? You guys all right? Bless you. You guys all right? Do you see the, well, okay. A lot went into. The really funny thing is when you learn this stuff, you don't see any of the history of what it took to get to the point where this is even something somebody thought to try, correct? There's a lot of shit behind this, right? They didn't just go, well, of course you make it. Why, what else would you do? No. So it took a while to figure out that this actually leads somewhere good. Because it doesn't just come to people, right? But I mean, getting to this point and you're like, okay, what if that was just all right, let's see what happens. That's roughly what happened over some years. All right, so then you just separate this. How do you separate this? What would it become?
On the other side.
By the way, I really hate the overhead, but I think I'm gonna switch to lectures on the overhead because then you got all these freaking monitors. I just don't like it, but I think that might be generally better. Because then you could just look there, it'd be crazy. For example, right? Not just you. Only you look away. So then this would be like, you have to pick something to be negative, correct? So if I move this over, let's see, it doesn't really matter. This will be u squared over 1 plus 2u cubed du. That's nice, correct? And then I can choose my x's to be negative, so that would be negative, what is it? 1 over x dx. Is that cool? So subtract this over, divide by this, and divide by that. Yeah. You guys are? So then integrating, I get negative natural log of x, and over there, can you guys see it's going to be, so I'm just going to slap down. This is 1 degree down, which means it came from a natural log. I really hope I'm not, now I've got to adjust this, correct? This is not the right answer, correct? Well, for one thing, it should be this, but that's all. Because if this was the answer, there should be a 6u squared, there's only a u squared, so of course there's a 1/6, okay, cute. Plus c. Okay. And there's a few different ways you can go from here to solve it. You're going to eventually have to do an e, right? I would rather move this 6 over here, does that make sense? Right? It's a little better over there, and of course my c changed a little bit, that's all right. You guys kind of with me? Somebody still with me at all? You guys are like, you lost me at, hello, yes?
Well, we need to solve for y from there.
It doesn't really matter which thing you solve for. Now you will have to eventually plug back in what u is, right? At the very end, you're going to plug back in, just like in 180, right? But from here, I can solve for x, for example, because it doesn't really matter which one is the dependent variable. I don't know. Okay. So this will be, is this cool? This is 1 over x to the 6th when I do e. And this will be, that comes out as a constant, and this will be, you can do it, Jeff, just 1 plus 2u cubed, is that right? Okay. Is that all right? And then I could, it doesn't matter what I do from here. Yeah, go ahead.
How does the algebra work for your C1 times that times?
Oh, okay. So again, I need us to see enough of this. So e to the natural log of this plus this, yes? When do I add exponents? When I was multiplying like basis. So this came from e to the C1 times e to the natural log of 1 plus 2. This is its own constant. So
Oh.
yeah.
So are we getting the part, so I remember, I missed last class, but I remember we were saying, identifying C1, C2 isn't too important now. Are we getting that part where we really want to identify C1, C2, C3?
The important thing about the C stuff is keeping track, and that's to get not just to get practice, but to be actually telling the truth when you're doing a problem. So if you just have C running all the way through, you could argue technically it's okay, but literally you're lying, right?
Okay.
Later it's going to become very in your face. You got to be careful
And that's
about
why I
it.
want to get in the habit
Yeah, so it's getting in the habit, but it's also the right way to do it,
now. Okay.
right? Okay.
So you just raised both sides to the power.
Yeah, I'm sorry, guys. I did this a little quickly,
I
but
think you mentioned
I
that.
brought the
still
negative
understand
6
that for a
up,
second.
raised e to both sides, did this stuff to that side, of course this side just becomes that. And then from there you can get the x alone, whatever you want to do, it doesn't really matter. Right? Don't solve for x, because again, you'd have to take roots and so forth. There's no need to do that kind of stuff. Oh, very last thing you should do, like I said, is replace that with y over x. Is that cool? Because that's what the hell it is. Yeah.
So it's fine to leave x in the answer when solving for x.
Oh, sure. You can have implicitly defined solutions. Totally.
Okay.
I want you to solve it when it's really, you can get x or y by itself without doing anything weird like taking roots or whatever. Yeah. Okay. Okay. Last thing. Did I manage? Oh boy! In the 2 minutes I have left, we'll do a little more of this next time, and I got to give you the practice test. But I forgot to look which Bernoulli did this. But Bernoulli's equation deals with does everything look good so far? Right? How do I mean by that? Does that look linear so far?
Yes.
Actually, let me put P of X. Still good? And then Bernoulli says, okay, what if I had that shit? Okay. Which powers of n do you wish that was? What,
0.
0 would be awesome, yes?
Yeah.
Because then it is just linear.
Yeah.
Or just linear. What if it was 1?
That's fine.
Then it would be like terms, right?
Yeah.
So if n is not 0 or 1, then what can we do? Bernoulli. So what Bernoulli says is use this substitution. Again, not the most obvious thing in the world,
So true.
right? But again, these were people that didn't have YouTube videos to watch, so they sat around next to the candle doing this kind of shit, right? Just playing around. People still do that, even though there are YouTube videos to watch. All right, I have no time. So I think next time, let me give you the practice test. Next time, I'll immediately start with, obviously, giving the quizzes back. I'll do a couple examples of Bernoulli's, and then we'll talk about the practice test or whatever else you want to talk about. Say again? Yeah, like I just said, I changed it. Guys, homework through 2.5 is due. 2.5, right? Not chapter 3 yet. Web assigned people, I don't think I even put 3 up yet. Okay, good. See, I was right. Okay, sorry. Did I already give you guys this? No. No. Sorry.
I can't even So all the homework is due the day of the test, right?
It's due when?
It's due the day of the test, right?
Yeah, so
Okay, cool. I'm through 2.3, I think, so I just need to do 2.4 and 2.5.
yeah, I've kind of been jumping around the problems here and there.
Awesome. Alright, I gotta run because my English class, we have like a special project thing today, and she said if I'm late to class, I did not get any credit. So,
All right, see ya.
I made a PDF copy. I basically made a document that has every single physics equation you'll use from tier 1 to 2.
I don't know.
Oh, I'm sorry, man. This one. Yeah.